Myself Lata Kulkarni, Department of Electronics, Maharani Science College, Mysore. In this session, we are going to study how to construct AMV, that is astable multivibrator, using operational amplifier and IC555. So what is AMV? That is astable multivibrator. That means it has no stable states. Let us study the circuit. So this is the circuit for astable multivibrator. Another name for the astable multivibrator is square wave generator. This uses the positive feedback. What is feedback? The process of injecting a portion of output back to the input is nothing but feedback. Two types of the feedbacks are there: positive feedback and the negative feedback. If input voltage increases by taking the output, then it is called a positive feedback. If the input voltage decreases, then it is called a negative feedback. Now let us move to the next slide. This figure shows the output wave. So as I already told, what is the output of this AMV? It is a square wave. So we are going to get this type of the square wave, and this is a voltage across the capacitor. And next, formula for calculating the output frequency. That is, our aim of the experiment is to find the frequency practically and theoretically. Construct the circuit of the astable multivibrator and find the output frequency practically and theoretically. What is the formula for the practical frequency? 1 by T, where T is time period of the square wave. Next, how to calculate the theoretical frequency for the astable multivibrator? That is F is equal to 1 by 2 RC, where R is the resistor value and C is the capacitor value. Now let us move to construct the circuit using virtual lab. So how to go to the virtual lab? Double click that virtual icon. This will open the virtual lab window. Now select the components what we want. Just now we have seen the circuit. In this circuit we are using how many resistors? 3 resistors. How to pick the resistor? Go to this resistor symbol. Just one drop down menu is there. Click on that drop down menu. It displays all the components. In that you select the resistor. We want the resistor and the capacitor. Okay, afterwards you close this one. Next we want the op amp. Where this op amp is present? It is present in analog ICs. And take this analog IC, close this toolbar. Next what we want? We want one CRO, where it is present in instrument toolbar. Select the CRO. Close this. Afterwards let us start how to construct the circuit in the virtual lab. We need the 3 resistors. It is having the 1 kilo ohm, but according to the circuit I need 2 10K and 100K. What you have to do means just to go to this resistor symbol, double click, it will open the resistor properties. In this, here we are having different tabs are there. If you want to give the label, you can give. So here I am going to give the label as R for the resistor, and the next tab is for the value. I want first is the feedback resistor is 100K. Just change the value, and here you are going to see the kilo ohm and click on OK. Now the 1K is replaced with the 100K. Next I want 2 10K. So what to do means just take this, take the Control C as the shortcut key, and next Control V. So it will paste the 100K, the same resistance, but what I want the 10K. Just change the value 10, click on OK. Now I want another 10K. So what we have to do? Select it, Control C, controlled way. Another 10K also I found. And next one is the capacitor. I need only one capacitor, that is of the value 0.01. Once again select that, double click. If you want to give the label, you give label as C, and next value what I want, the 0.01. Then click on OK. Now let us start to construct. So for this is 100K is the feedback resistor, and this is the symbol of the operational amplifier. Here we are seeing this is a inverting terminal and this is the non-inverting terminal. According to the figure, this is, if you want to just change the position, you can change, because in the circuit it is in the form of vertical, so that it is very easy to connect. Let us here, according to the circuit, pin number 2 is connected to one end of the resistor, and the same way pin number 2 is connected to one end of the capacitor. Another end of the capacitor is connected to ground. Let us take this ground, where this is present, here present in this sources toolbar. Take the ground, just to close this to avoid some confusions. Okay, and next just you do like this, then all are going to remove. Do the connection for this capacitor. Next I want these two 10K also should be rotated. Let us take these two here. Okay, just to rotate it. Rotate, and make these two connections, because these two are connected, and after these two connected, next let us connect this to pin number, this is the pin number 6, and the pin number 3 is connected to in between these two resistor, and this ground is on another end of this resistor is also connected to ground. Let us connect from here to here. If it is not possible, just take this one here and try to connect it to this ground point. Actually it is not showing any connection. In this, when you take this cursor, it is showing the connection. When it is not showing means, what we have to do means, we have to take the connector, where the connector is present in this basic toolbar. So take this connector. After taking this connector, what we have to do means, just so it will show the connection, and drag it and place here. So after placing this one, next negative of another end of this series resistance is connected to this connector. Connecting, let us see, it will going to connect. Next this where is the another end of this feedback should be connected, it is connected to pin number 6. And next our aim is to connect the CRO. As in the first virtual lab video, we seen that this is the channel A, channel B, and this is the ground, and this is a triggering pulse. So we have, this is channel A. Let us connect channel A output to the, if it is not properly connected, select and delete. Let us connect properly. If it is not properly connected, then we are not able to get the output. And this positive is connected to pin number 6. Negative is connected to ground. You connect anyways here. If it is having like this, then it will not working. Just delete it and try to connect properly. If this is not possible, then we will take the another ground point. Now it is okay. But you see here, this ground is detached. If it is like this, means then it will not going to conduct. What we will do means, here this is not connected to ground. We will take another ground and connect it for the smooth operation. Because all the ground should be connected properly, then your circuit is going to construct. You see here, only this is connected, this is not connected. Let us connect here. Now the ground is connected. Now the circuit construction is completed. Okay. And if you want, you can give the name for this also. Select, double click, and next here label is there. If you want to give label, you can give. If you want to take the numbers, let us, actually I have designed it for LM741. Click on OK, then it will display LM741. If you want the color for the output, just output, select and double click. Here you select the color, your output will be this color. Click on OK. Next, switch on the circuit. So we want to see the waves. So here why it is coming like this means, somewhat frequency we have to change, then we are able to get the square wave at the output. Just I will expand and I will show you. You are going to get the square wave. Okay, and this point to this point, it is called the time period. Okay, according to the practical, just you take the time period and calculate practical frequency using 1 by T and theoretical frequency using 1 by RC. Okay, the same experiment is repeated for the different values. Let us change this. Output is not displaying properly. Color is not going to see. So just you change this value, because we have to take minimum 3 readings. Just I am going to show you for 0.03. Click on OK. Once again you make it 0. Switch on. You are going to see here the time period is when your capacitor is changing. That means you are increasing the capacitor. There is change in the time period. Okay, the experiment you are going to repeat it for the different values of the capacitor. You are able to get the square wave. Okay students, and remember that you are calculating the theoretical frequency and the practical frequency. Both should be equal. Then your practical is correct. Okay, and next I will show you the another one experiment, that is AMV using IC555. For that, what happens, I am not going to construct it. Just I have already constructed. I will show you the output of that the IC555, and I will show you this outputs. Okay, you see here. So this is the IC555. I have already constructed. It also needs the 2 resistors, 2 capacitors, and the CR1. And this is the power supply. Just you connect it according to the circuit. Just you switch on the circuit. You are going to get the square wave. Okay. Once again, take the time period from this end to this end. What is the formula for taking the time period? T is equal to number of horizontal divisions multiplied by time per division. Okay. calculate the frequency theoretically and practically by changing the values of the capacitor also. Okay, here also the practical and the theoretical values should be equal. Okay, thank you students. Please try in your home.